My name's Jorn. I'm from the Solutions Engineering Department, and my friend and colleague Glen Kosaka is here. He's the VP of Product Management, and we're here to talk about enterprise scale security and compliance inside of your container and serverless environments. And you'll notice this is a whole lot of elements that are related to the latest version of NewVector that just came out this week. We're really excited about it, and I'm hoping by the end of this, you're going to be excited as well. We're going to do a little bit of QA at the end. I'd also like to point out and remind you that we do have an exciting ebook attached to this presentation, so please download that. It's free while you're here. It's 10 steps to automate container security inside the CICD pipeline. Also, this webinar is being recorded. We'll get that recording out to all attendees and everybody who signed up as soon as we possibly can, later today or early tomorrow. So let's get underway. Taking a look at today's agenda, we're going to talk about some existing power that's inside of NewVector and also some new enhancements inside. So we'll go over vulnerability management, compliance. People are very excited about getting compliance inside of their container environments. We'll also look at runtime protection and how to mitigate zero-day threats, introduction of serverless support, and especially at the large scale, what you're going to do to try to manage multiple clusters. So you're going to see a federation of policies inside of multi-cluster management, sort of a single pane of glass approach, security as code using CRDs inside of Kubernetes, and some deeper custom RBACs. A matter of sort of housekeeping here, you're going to hear Glenn and I probably use the word Kubernetes kind of generically here. Remember, we're talking about all sorts of container platforms from either Docker, Kubernetes on premises. We also, NewVector runs extremely well. It's supported in environments like OpenShift and Rancher, as you can see from the logos at the bottom of the screen. So setting the stage, container security it really is difficult. In fact, managing container environments is difficult. I know the more I learn about Kubernetes, the less I feel like I know. The environment is changing. We're distributing things across lots of worlds. Hyperscale between pods are coming up, going down. That's the nature of this environment. There are brand new attack surfaces every day. And the reality is you've got real low visibility into what's going on in the environment, especially on that network inside of your organization. Again, it's ever-changing environment. So what do we do about that? Well, let's go talk about vulnerability and compliance. It's questions that we get all of the time. How do I mitigate risks inside of my environment? We're excited to announce that really NewVector is one of the fastest vulnerability scanning engines, according to our customers, is now faster and also infinitely scalable. So it's easiest to explain how that works by explaining how NewVector gets deployed inside of your environment. NewVector is a container native, Kubernetes native security platform. We immediately install, when you're doing NewVector, enforcers. They're on every single pod. They're deployed as a daemon set. So every time new nodes or new underlying VMs come up inside of your environment, they're deployed. They're doing the heavy lifting and the enforcing across your environment. NewVector also installs controllers in your environment. There's one that's in charge, and we do an active passive for HA. You'll notice in my example, I've got 5 nodes in here. There's 3 controllers because you always want an odd number so that in case there's any outages, they can always elect a leader. And that web UI is running also as a pod, as a container inside of your environment, so you can get access to the interface. What's changed now, if you've been a longtime NewVector user, is that the scanner is now a discrete container or pod inside of your environment. So if you've got a lot of images that you need to scan and need to scale out inside of your environment, we're now seeing real customer testimony where they've had scanning that's taken weeks with other tools has been reduced down to a day or even hours using NewVector. And finally, in that deployment, there is a cron job that automatically updates that CVE database to make sure that you're up to date for all of the vulnerabilities inside of your environment. In response to a lot of common questions, because it's a container native deployment, we're not doing any sidecar proxies or any code injections, so you don't have to install agents. We're not relying upon IP tables, it's not eBPF, and we don't just rely on port labels. NewVector is doing this intelligence native to the Kubernetes environment. So let's take a look at your typical CI/CD pipeline where NewVector comes inside of your environment. A developer deploys some code. It's going to be part of any sort of CI/CD tool, whether that's Circle CI or Jenkins or other CI/CD tools. Yes, we're able to scan those images for vulnerabilities. Of course, when images get put up to some registry, NewVector is able to scan multiple and custom repositories, whether they're public or they're private repos inside of your organization. When those images and pods get deployed inside of your environment, NewVector is there to make sure that they are scanned for any vulnerabilities and compliance, either in a dev test environment or inside of production. Anytime there's a change, we're going to be able to see what's going on in your environment. And we're really excited to introduce serverless, which you'll see a little bit later on in our presentation. So speaking of vulnerability and compliance, NewVector makes it really easy to see all of your compliance issues at a glance. It's very easy to do built-in reports plus custom reports inside of your environment. Industry standards are all there, and we've got some brand new customizable templates and secrets detections and rules inside of NewVector. Very popular requests. People are really, really excited about that. And probably that's enough of the graphics. Let's go right straight to the interface, a live demo of NewVector 4.0, and I'll hand the talking stick over to Glen. Glen, take it away. Thank you, sir.
All right, thank you, Jorn. So let me show you the NewVector console. I'll give you a brief tour just in case you're not familiar with NewVector, and then I'll focus on what Jorn talked about, which is the whole vulnerability and compliance management aspects. So first of all, there's a summary of the security exploit risk, which includes both the runtime environment as well as the vulnerabilities. There's a view of all of the network traffic, all of your assets, including containers and hosts and platforms, the NewVector controllers and enforcers. These are the rules that are set up to control and monitor the runtime environment and protect it. Serverless security we'll talk about later. The security risks tab offers vulnerability and compliance management. So as Jorn talked about, first of all, in terms of the architecture, NewVector is deployed on every host. In fact, let's take a look here, and we could see here in my GKE cluster that you can see several containers are running in the NewVector namespace. Now, as Jorn mentioned, there are 3 controllers. There's an enforcer, which is deployed to every worker node. And if you are managing your own master nodes, it can also be protecting the master nodes. The manager is presenting this console interface. And here's where you see what's new in 4.0, which is scalable scanner pods. So right now, by default, we have 2 scanners running. And essentially what's going to happen is whenever an image needs to be scanned, the controller, the lead controller, is going to send that job to one of the scanners. Now, this is critical for enterprise deployments because while initially you may only have 500 or 1,000 images in the registry that needs to be scanned, you can see how that can quickly grow as new applications are deployed, as updates to those and new versions of those are constantly deployed every day or every week. That can explode into 10,000, or we've seen even 100,000 images in that registry that need to be scanned. And for those purposes, that's why you can easily scale up the number of scanner pods running, just like you can any Kubernetes deployment. Just change the deployment to 10, and instantly Kubernetes will add another 8 scanner pods, and the controller will detect that and then assign the scanner jobs to the available scanner pod. The updater, as Jorn mentioned, runs once a day and updates the CVE database, which we publish as often as daily with the latest updates. So let's go back to the interface. Now, Jorn mentioned that the first place you could do vulnerability scanning is through the build process or build phase with a plugin, Jenkins plugin, GitLab plugin. And that in that way, you can check for vulnerabilities while the developer is building the image and reject that if there's a fix available, forcing the developer to fix that. So in order to scale to hundreds of developers and thousands of images being submitted every day, all of this needs to be automated. So you can incorporate NewVector as a plugin to automate that process. You can also use our REST API to do any of the actions, including scanning, that you see here in the interface. Now, once that image passes that build phase, it's going to be put in a registry, and it's going to be scanned again in the registry. Now, as I mentioned, the reason that's critical is vulnerabilities can be discovered after your images are put in your production registry. So you need to continually rescan those registries. And we support all of the common public cloud as well as private registries. And you can turn on what's called layered image scanning. And what that provides to you is a full layered view of the vulnerabilities found in the image. So for example, in this scan, 128 high vulnerabilities were found. 87 of those were found in this layer of the image, and this was the command used to build this layer. So it makes it easy to inspect the image. Now, new in 4.0, what we've added is a compliance tab where we're going to check for compliance issues with the image. Compliance issues are going to be applying any of the Kubernetes or Docker image-based compliance checks that relate to images. It's also going to apply checking for things like file permissions as well as secrets in containers, images as well. So here on this scan, you could see that there's a number of warnings, including a whole bunch of binaries where the permissions are broader than are typical or should be granted to a binary running in a container. Essentially, a best practice is to not allow binaries to run with a root type of privilege, because that can result in a privilege escalation. Now, if I go to another image, let's take one of this, the Docker demo image. And again, I go to the compliance tab. You could see here that this image has two warnings in it, and these are related to secrets detection. So we're looking for various types of secrets. This can also be customizable and run in containers at runtime. But we're looking for things like, in this case, you could see, AWS secret keys or access keys. We're looking for private keys, SSH keys, common things, API keys that may be used to connect to your social media as well, because those could be accidentally embedded into images or containers. And we're going to be able to warn you about that. And of course, the next step in the scanning process is to then create admission control rules, which are going to prevent the deployment of a either vulnerable image or an image that does not pass your compliance check. So in admission controls, we're going to integrate with the Kubernetes and OpenShift admission controller, which will stop all deployments and then wait for NewVector to make a decision based upon the rules that you have established. Now, in our previous releases, we've had all of these where you can base the policy or the rule to block an image based upon high severity images or vulnerabilities. You can even say only if there's a fix available, then block it. But if there's no fix available, there's nothing we can do about it. But NewVector is going to protect that in production. Now, what we've added in version 4 is environment variables and environment variables with secrets, as well as those who have image compliance violations like we just took a look at. So we've added the number of ways that you can detect problematic images that are trying to be deployed into production. and enabling you to just warn you about that, or in a protect mode, we will actually tell OpenShift or Kubernetes to block that deployment. Now, of course, we know that some images are going to have to be allowed into production with some vulnerabilities and with some perhaps some compliance issues. So this is in the compliance and vulnerability interface. This is your Explorer interface. This is where you can review all of your vulnerabilities and compliance issues. You can see, for example, this high vulnerability impacts these images and these containers. You can also see which ones are running in the production environment and can be told which ones are protected by NewVector in the production environment. There's new in 4.0, you can add dates. So look for vulnerabilities that were only published, let's say 2 weeks ago, because those are the ones that I want to alert my dev team to make sure that they need to fix those. Because, you know, let's say I have a policy that says I'm going to allow them 2 weeks to fix a vulnerability once it's detected. So I only want to build a report of things that were reported more than 2 weeks ago and where there's a fix available. Now, in the compliance section, there's some new things that we've added as well. This enables you to provide reports on CIS benchmarks, as well as custom compliance checks that you have configured to run on hosts or containers. We've added here the ability to generate industry standard compliance reports. So let's say you want a PCI report. Once I apply that, I'm only going to show the compliance checks that I have identified are PCI. And of course, I can generate a report to that, on that, give it to my team as a remediation list for them to work on. Now, you can customize those compliance profiles through this new tab. We provide these templates that enable you to customize which of these checks are applicable to these industry standards. So for example, if this check, I would like it to be included in my PCI compliance check, I'm going to add that as well to it. If I want to filter just on PCI checks or GDPR checks, I can do that here as well. In addition to that, you can also customize which of these industry standards are applied to certain assets. So let's say I only want the GDPR and HIPAA compliance check to be applied to image scans, but I want all of them applied to nodes or containers. Here is where I can customize where I'm going to apply, or the target of those compliance checks. Now, if I've enabled namespace-based compliance checking, this is where I can specify, for example, for this demo namespace, I only want to apply my PCI compliance check. But for my default namespace, PCI is really not relevant. So I only want to apply the NIST template to it.
Glenn, I'd like to congratulate you on two instances of great mind reading. We had two questions come in. One was earlier from the deployment. One was earlier from deployment. Luis, I want to make sure I'm pronouncing Luis correctly. Luis had asked if when NewVector is deployed, can we deploy it to some of the master nodes and the answer to that is yes. You just can change the tolerances to make sure that your master nodes are allowed to.
You can either use labeling, node labeling, taints, or tolerations.
Easy to do. We're happy to show that to you. And then Natalie dropped a question in, and you were answering it right away. And the question is, can I confine some of these compliance checks specifically to something like PCI-DSS, so that I'm not trying to do that kind of compliance to an environment where it's not relevant? And you answered that as well.
Absolutely.
So if anybody else has further questions, wants explanations, please type that in the QA section. We love those. Thanks.
Awesome. Great question. So, Jorn, I think I covered everything that you mentioned, right?
I think you did.
Overview.
Okay. Let's go on to the next chapter. We've got we got a heavy one today, don't we? So before the audience, let's go back to that that CICD, the left to right that we're all so very familiar with. Glen just got done doing a great job showing you a lot of the vulnerability and the compliance checks you can do inside of your environment. And some of us are very, very familiar with that, but there's a little bit more, right? And we hear about runtime protection all of the time, and it's a phrase that sometimes has gotten a little bit watered down, because what does runtime protection really mean? Well, let's look at a typical instance, because as you can see up here, vulnerability management is fantastic, but vulnerability scanning tools give you reports. Managing vulnerabilities is still a kind of an expensive task. Like Glen even showed you, we're stopping some things that maybe there are fixed, maybe there aren't, right? So you may get a report back to your developers going, look, we've got all these CVEs, you need to do something about it. Well, that needs to get prioritized by your development department. Or, like Glen showed you, what if there are vulnerabilities out there in the world that don't have fixes? Or even worse, it's a vulnerability that nobody's reported yet back to those common databases. What do we do about that? Well, in comes NewVector with our patented technology about protecting those real, true runtime vulnerabilities. As I'm sure you're familiar, when you deploy container environments, especially like Kubernetes, being able to see into the network is nearly impossible. In order to make the environment work the way it's supposed to work and have a dynamic environment, the network's been flattened out, usually into some RFC 1918 space where you cannot see the traffic and packets going by. That leaves you a little bit exposed. NewVector has a patented approach that allows your environment to be visible all the way from layer 3 up through layer 7, which gives you the ability to do those zero-day countermeasures. And how does that work? Well, what we're doing is applying a tried and true and tested standard for security by using permit rules inside of an environment with an implied deny any at the bottom. So NewVector is able to pattern match your applications inside of your environment, and anything that's out of the ordinary will be stopped right away. Even unknown CVEs, we're able to do automated behavioral learning, so you don't have to worry about writing these rules by yourself. NewVector can look at your environment, match that out for the patterns, go into a discover mode and say, hey, here are some rules you might want to try inside of your environment. We're able to go into alert mode, which allows you to test those as sort of a dry run and then go fully protected inside of your environment. Extremely powerful and unique to NewVector. And the best way to demonstrate that is to put poor Glen back to work and show you live inside of the interface. Glen?
Okay, thanks, Jorn. So, on this release, we really focused on the vulnerability compliance side and some of the other things, enterprise scale capabilities. And so what I'm going to show you is some of the runtime policies of NewVector. And we could do a whole session just on runtime and how to prevent attacks during runtime. So I'm going to give you just a high-level overview. And if you do want additional information or insight, please feel free to contact us and we'll schedule a private demo for you. So first of all, we're going to, as Jorn said, be able to detect all network traffic, because essentially we are filtering, we're doing deep packet inspection on all the connections between containers and ingress and egress. And so in the discover mode, we're going to learn all these connections. We're going to be able to display them to you in real time. We're going to be able to write these whitelist rules that are going to allow that behavior. Perhaps you're running this in a test or staging environment. And then once you've observed everything and locked them down, we're going to be able to set you in a monitor or protect mode. And that's where you're going to be noticing attacks or violations. Under the covers, the way this is all managed in NewVector is each group or deployment you could think of is noticed in or discovered in NewVector in a discover mode. And when you run test traffic through it, we're going to whitelist all the network rules, the process rules, and you can create customized file access rules for those as well. And once you are comfortable with that, you're going to lock that down into a monitor or a protect mode. And that is where in monitor mode, we're just going to alert you if any of these network rules are violated, or protect mode means we actually are going to run like an inline firewall, and we're going to block those connections. But you can set that protection state differently depending on the sensitivity of each container service that you're deploying. If you also notice that's new in this release is this scorable checkbox. And what that is doing, let me just set that back. So what that is doing is it's controlling if the any of the compliance violations and vulnerabilities are being scored in the security overall security risk score. So in this way, you can only score the containers that you think you want to track. You can eliminate system containers if you want, or test namespaces as well. So that's a cool new thing. Now, we are a true layer 7 firewall, so you can manage these rules just like you can in any firewall, except that these are layer 7 rules where you're going to say from this container group to this container group, it could be external. What is the application protocol allowed to be spoken? Or if there's no application protocol, it's a custom application, what TCP and port is it on? And as I mentioned, we'll be able to block any unauthorized connections. DLP sensors are using our deep packet inspection for looking for things like PCI violations where there's credit card data, or if there are social security numbers in the actual network payload. So in addition to the built-in credit card and social security ones, you can add your own regular expressions and then apply those only to the network streams coming out of containers that are sensitive. So that's a kind of a high-level overview of some of the runtime protections that Jorn provided. The one thing I'll mention is, as we talked about, if you have to deploy a container into production that does have vulnerabilities. So for example, I go here, I have my node pod, I look at my vulnerabilities and I go, whoa, look at all these vulnerabilities. Let's say there were no fixed versions available. You can rest assured that once you put this container group into a monitor protect mode, there is no way that vulnerability can be exploited without it generating additional process activity, file access activity, or network connections. So NewVector is going to detect that, and in protect mode, we're going to block that. So that's what we call virtual patching, and that's why if you do have the protection mode on, your vulnerability, your overall risk score will be lower.
That's really powerful. Very, very powerful.
All right, back to you, Jorn.
All righty, thanks, Glenn. You don't get much of a rest because I'm going to send you back for more demonstration here really in a moment. Another exciting announcement from NewVector 4.0 is support for serverless environments. As you can see on the screen, NewVector has now announced support for serverless security for AWS Lambda functions. We're using that open source serverless IDE. So now your development teams can trigger vulnerability scanning with those serverless functions. We can remove those vulnerabilities if we see them running. We support, obviously, functions inside of Python, Node.js, Ruby, Java. As you could probably also imagine from the interface, we're also allowing those custom admission rules. So just like Glenn had demonstrated before up against, say, container Kubernetes environments, you can customize those admission rules so that when you're deploying code, you can decide how much you will allow through, what you won't, what those reactions will be, and embedded secrets detection. So not just against your images and your running pods, but we're also able to detect secrets inside of serverless and Lambda functions. In the time we've got left, we'll see if Glenn can show us that part. That's really exciting. We got some projects set up inside of AWS that are pulled right into NewVector.
All right. So the way serverless security works is in the console here, you'll see this interface, and you define a region where those serverless functions exist. And then we will scan those serverless functions that you have uploaded to your AWS project. So you create the project, you give us access to it, we automatically scan those functions, for two things, vulnerabilities as well as compliance checks like secrets that Jorn mentioned. But in addition to that, we're also going to look at the permission level granted to those functions, and we're going to provide you a kind of alert if the permission level is high. Now, high to NewVector means if it's broader than the recommended AWS function set of permissions, or if it's going to or has permissions to access databases and things like DynamoDB or S3 buckets. In addition to that, if we determine that it's just got some pretty innocuous permissions, then you'll see a low or even a medium here. And so that's how we're doing this. We can even show you how the functions exist. If this was a multi-region environment, we would show you where your functions exist and where they're deployed in the different regions that you have configured in AWS. Now, in terms of the build phase, as Jorn mentioned, you can also scan functions as the developer is building them in the serverless IDE framework. So there is a plugin you can search for and install the NewVector scanner plugin into your serverless IDE. And then we can scan the function there. And again, just like containers, we can reject it if it's got too many vulnerabilities. We have another feature in there where if you identify a unique security key when you configure that IDE plugin, then we will actually link it to the functions that we're finding here in your AWS project. And what that enables you to do is to avoid storing your function source code up in Lambda. You can just store your binaries. But even then, we will know and be able to display to you the vulnerability scan results from the plugin in this interface. Even though we're not scanning it actually in your AWS account, we're scanning it from the IDE plugin. We can correlate those two and identify those two functions as being the same function. So that's a cool little feature that we've added as well.
And the thing I'd like to add for the audience as well is to mention that all of this is available via NewVector's fully featured API. So if you're doing everything programmatically or you just are allergic to looking at graphical user interfaces, the API and the CLI is there to bring all of the security and those workloads right into your environment. And finally, in our last chapter for today, we're going to talk about multi-cluster management. We've improved that in the latest version of NewVector, and it's a really popular question. NewVector 4.0 has some enhancements that our largest customers have been asking for and some improvements. And we're really excited to talk about them. So what I'm going to do is talk about not only a hypothetical situation, but this is actually how we're running NewVector inside of our demo environments. So let's say you've got a GKE environment out there, and you've got a couple of other clusters that you're trying to manage and you want to manage security across. And instead of having to log into different environments, NewVector gives you the ability to not only have a sort of single pane of glass, one administration console, but the ability to do top-down rule enforcement. What we're talking about here is writing those rules that Glen just showed you earlier in the interface, but making those rules federated rules so that they're applying across your entire domain inside of your environment. So those child clusters have those unbreakable rules that trickle down from the master cluster, but you also still have some autonomy with local administrators inside of that environment. So now we're not running around inside of a global organization having to apply rules each and every time or worried about whether different clusters are following rules that are organization-wide. But another situation may pop up where you have maybe a cluster of Kubernetes that you don't want talking to other ones. It's isolated off, it's air-gapped for some reason, and you want to be able to share those rules from one to the other. And that's where this concept of security as code comes into place. So we can take all of those rules and even the mode that they are in, from discover all the way over to protect, and export those rules as a YAML file using CRDs to apply those rules to another cluster. So not only are we able to do that inside of clusters that may be air-gapped, but you can also start doing some version control because it's a native YAML file using CRDs. We could maybe check it into a repository, do diffs against it, be able to inspect for things like security drift from a dev test environment over to a production environment and say, hey, has this application changed? Why are these rules changing? And be able to apply those securities there. And yes, you can mix those two modes. Also, we'd like to announce that we've strengthened and deepened our RBAC controls inside of the NewVector interface. These are some powerful new features that make large enterprise scaling a lot easier inside of your environment. And to show you that, it's Glen again. Thanks, Glen.
All right. Yeah, I'm going to switch over to my multi-cluster demo environment. This is the master cluster is running on GKE. And as Jorn mentioned, we're talking about enterprise scale. And while your first deployment may be a simple deployment and a single Kubernetes cluster, that's going to rapidly expand as you have more dev teams using it. You have to scale outward to 50 nodes or 100 nodes in that single cluster, or you have to start having multiple clusters and you want to be able to manage those efficiently. And so we provide this interface to easily manage multiple clusters. In this case, I'm managing the 4-node cluster running on GKE, but I can easily switch to other clusters. For example, now I'm looking at my cluster running on Azure AKS. So whether it's public cloud, hybrid, private cloud, you can join them all together and manage them here separately or together. Now, one of the things that comes with multiple clusters is you may have a security team that wants to deploy kind of global security policies across all clusters. And so we provide the capability to create what's called a federated policy. And just like we saw network rules, process rules, file rules, admission control rules in the single cluster interface, you can now create these for multiple clusters. And once you create these rules, they will be pushed automatically into every cluster. So if I go to my policies and I look at my network rules, you will see that there's a couple that show up that are federated. And I can't edit them. I can't select them and edit them or delete them because they were pushed by a federated administrator and they can only be changed through this federated policy. So a local admin that logs in is not going to be able to change any of those. So that's one great way of federating policy. Now, the other way of managing policies across clusters and federating them is the CRD aspect that Jorn talked about. That's custom resource. That's the ability to define all of these rules in the form of a YAML file. So let's say that I've gone through my learning process. I've locked down Node, Nginx, and Redis in my demo environment, and now I would like to, review that and save that, review that with my dev team, make any changes needed, and then check that into my Git repository. So here is a code version of all the rules that we just took a look at. Nginx in the demo namespace can do an egress, can also talk to Node using the HTTP and WordPress applications. Let's say there's also SSL going to be used. I simply edit this file to add another application. Here I see certain processes that are allowed to run in every container as well as external access. I'm allowing external access from Node to Google.com. So all of the rules, the process rules, the file rules, the network rules are established or declared in this, and this can be the security policy of record for this service. Once I review that with my dev team, check it into Git, now I can say, okay, I've got my production cluster, which is running on AKS, and I simply do a kube control apply or create and push those rules into that cluster. So you can see here, there are CRD identified rules in here. For example, this Node.js pod has a bunch of CRD rules in them. These network rules are now showing up as CRD rules rather than NewVector learned rules. Just like federated rules, these cannot be changed through this interface. You need to change them by checking out the code from the Git, going through your normal approval and pushing process, and then pushing them back into NewVector to change them. That way you can maintain some source control over the policies and rules in NewVector. And the last thing that Jorn talked about was the ability to more granular customize the roles that users are assigned to be able to do. We provide a certain set of default rules, of course, admin, view only. CI integration role is really, you'd use that for like a Jenkins plugin so that it can only trigger scans, but it can't really do anything else. But if that is not sufficient for you, let me switch back into my GKE cluster where I'm a master admin. I can now go into my roles and I can add a custom role. Let's say I just call it my custom role. And I can add whatever permissions I want. I want this person to only view registry scan, runtime scan results, but I want them to be able to change and manage runtime and admission control policies. So I've added a custom role now. When I create a new user, I can add them to that role, as well as if I don't want to assign a role, but I do want to limit the certain role that a person has to a specific namespace, I can also do that. So you can have namespace users as well. So with these powerful features, you can now more efficiently scale NewVector, whether it's within a cluster to other enterprise users, or whether it's to multiple users in different clusters. All right, back to you, Jorn.
Thanks, Glenn. The good news is I'm letting you off the hook for demoing the interface now. you can rest.
All right.
Ladies and gentlemen, we're getting towards the end here. We've packed a lot in. We were doing some very high level. As a wrap up, I'd like to just point out you're probably doing already a lot of great things inside of your container environments. You're certainly doing these foundational controls and some of these basic controls, and these come right from Gartner. This is their technical report from April 2020. You can go to them and buy that report from Gartner. But there's also these risk-based controls that they talk about, where you're doing vulnerability management inside of your organization. There we go. Trying to make the slide advance. Or CVE management, like you already saw, and application behavior controls, and also layer 7 network segmentation. We didn't ask for them to do this, they didn't mention, but we noticed that inside of that report, we were called out, where they said, and I'll read it back to you at this time, most of the commercial network security add-ons you can configure to do segmentation and micro-segmentation inside of your environment aren't really delivering much higher granularity, but the exception there was NewVector as a container security product. Again, like Glenn mentioned, that allows you to do, because of that layer 7 micro-segmentation, you're able to do things like virtual patching, that even if those vulnerabilities are inside of your environment, they get stopped, not just reported, but stopped inside of your world. So as a wrap up, NewVector is really a pipeline to production security complete environment. We're doing compliance and DLP inside of your environment. You saw those great reports, those customizable reports. You can have your auditors lean over your shoulder and you can give them a good thumbs up of what's going inside of your environment. We're fully integrated with your software development lifecycle. Yes, we have even, somebody had put a question in there about orbs for Circle CI. Yes, there is an orb for Circle CI for NewVector. And Down across the bottom in these green boxes, these are things that are unique to NewVector. That's that layer 7 application micro-segmentation, the 0-day attack prevention. You don't have to know about a vulnerability in order to stop it going inside of your environment, and that assistance from behavior baseline and policy automation. There's machine learning inside of the organization, inside of your environment, so that you don't have to write firewall rules from scratch. NewVector will suggest those rules based upon the exercising of your application. So that's it. We're going to try to get to some QA in there. Again, if you've got questions, please type them inside of the chat box. Another reminder, there is that great ebook that's right inside of the interface. Please download that. We encourage you. The recording is going to be sent out very soon. And if you have any more questions, you want to get a hold of us after this conference is over, it's info@newvector.com. Now, Young, are you able to see any of the questions inside of there? I've got some that you said there are some more not showing up.
So I do have some, and one is from Gobind. And then either you, Jorn, or Glen can go ahead and answer these. But how are these auto-generated network rules enforced if you are not using sidecars, eBPF, and IP tables?
Oh, that's a good question. He's probably like, this looks like magic, and I don't believe it. Yeah, so NewVector is actually, it's a patented process, and we could probably, if you want, we can send you the links to the patents. Very simply, NewVector is integrated right at the Linux bridge. So we're seeing that traffic before that traffic is told to exit the pods or the containers inside of the environment. But no, there are no sidecars being deployed.
Yeah, I would add that one of our co-founders wrote all the deep packet inspection engine technology at Fortinet, which is a layer 7 firewall company. And so we built our own packet filtering engine because it needs to be fast, it needs to sit on every host, it can't be a sidecar, and it needs to be extensible to multiple protocols and attack vectors and things like that. So it's all technology in the enforcer. You might have seen the enforcer pod running on every worker net.
Okay, and then do you provide L4 rules from the same person, Gobind?
Oh yeah, absolutely. Those rules are looking at 3 all the way through 7. We're obviously looking at what ports being used, but there's deeper packet inspection and intelligence wherever available and practicable, all the way up through the OSI stack.
Yeah, and IP and port rules are frequently used for egress control. And we did a whole webinar on egress control where you can specify either a DNS name to allow pods to connect externally that can be resolved to a DNS name, or it can be a specific IP address and port, for example, a database or an app running outside of the cluster on a VM.
Okay, and then from Anton, could you please explain how you intercept the traffic from containers? You've told there is no sidecar or something like this.
Yeah, I think we already covered that, but if there's any follow-up question, Anton, just put it in the chat or question.
Okay, and then from Siddhar, so this is a very long question, okay, you guys? Can you please show how to track age vulnerabilities? Example, if a high vulnerability stays open more than 60 days, we report that container as out of compliance with VM STD. It would be great if you can show how to track this in NewVector. Is that something you can do, Glen?
I can show part of that. So we did a webinar 3 months ago with the Cooperators Insurance in Canada. And in that one, our customer there, Nitin Cole, demonstrated how he does exactly what you're talking about. Now, what he uses is really a combination of some of the things in the console, but also a lot of use through the REST API. And the reason is the REST API contains all of the information about the scan results, including when it was detected, when that CVE was published, all of that. So I can start with, I think it was in the vulnerabilities tab. and being able to, first of all, show the publish date of the CVE. So this is where you're going to be able to say, okay, if the CVE only existed for a certain amount of time, then let me know, and then I'm going to remediate or let the developer know if it's, let's say, more than 60 days old. And so what some of, like Nitin, what he is doing is he's actually adding more custom logic to that flow, where they are annotating their images with metadata like the developer name or the group name. And so when they get a scan result, they can pull the developer name and they can then automatically notify the developer that there's a pod running in production that has a CVE with a fix that is more than 60 days old. And they can even quarantine that automatically. And he's doing a lot of that customization through the REST API. But there are other ways that you could do it. For example, in admission control, you can also look at vulnerability scans when you add admission control rules. So, let's say there's a fix, and then let me just move the screen. So you could see here, I'm going to block deployments for a CVE where there's a fix, and maybe only if there's more than 2 high CVEs, and then reported more than, well, I think you said 60 days ago. And so, you'll be able to then create that rule, and therein you can block any deployments that don't meet your criteria. So I hope that gives you a sense for how we use some of those dates in NewVector.
Okay, great. And then what kind of scale per cluster, and this is from Glen again, example, max nodes, max pods, can you support with NewVector's daemon set for security?
Yeah, that should be pretty easy to do with your deployment policy.
Yeah. Yeah, I mean, the enforcer is deployed as a daemon set. So the containers we looked at here, controllers are a deployment with the default of 3. An enforcer is a daemon set. So every schedulable node in the cluster will automatically get that enforcer. If you add or auto scale that cluster, Kubernetes is going to put an enforcer on it. If you turn on master node scheduling, the enforcer will go there as well. And in terms of the scale per cluster, there's no theoretical limit that we've seen. We have customers, we've seen hundreds of nodes in a single cluster, but there's no theoretical limit to how many nodes you can run in a cluster with NewVector.
Okay, and then is there like a trial, or how does NewVector pricing work?
So,
Jorn, do you want to take that?
Yeah, so yes, we absolutely do POCs. You can, hands off or certainly hands on. Walk you through that. NewVector is actually very, very easy to deploy, as you've probably grokked by now that it's Kubernetes native. It's really getting the image in a few kubectl commands, and you're up and running, and you're starting to get information about your environment immediately. I like to report that it's also easy to uninstall if you'd like. Pricing. Our pricing philosophy is really based upon nodes. There's some core count that's inside of there, but we want our customers to use and enjoy the product. So there's essentially unlimited usage. We're not counting any kind of security against usage or number of pods or containers. It's really just against nodes at the back end. But if you reach out to us, we could certainly get somebody who's an account representative to make sure that they customize a quote for your needs.
Okay, and then just tracing back to the previous question, so what Gobin had meant was, do you see any performance degradation with NewVector as you start scaling the number of nodes in a cluster?
Yes, we see this question. I knew that's where you were probably going, my friend, because you look at all this power and you wonder, wow, is it going to melt down my nodes? No, actually, NewVector is very low footprint, low overhead. Like Glenn mentioned, our founders wrote this to make sure that it's scalable with your environment. We've got some metrics that we certainly can share, a lot that came directly from our customers. When you are in, for example, when you're in a discover or an alert mode inside of NewVector, that's no overhead at all beyond some of the pods and containers that are running. And then we've seen from our trials that if you're in a full protect network inspection mode, use is usually, and Glenn, keep me honest here, well south of even 5% in worst case.
Sure, absolutely. I mean, the good news is this is a truly distributed firewall. So the enforcer, as you add more nodes in the cluster, you get another enforcer. And if you have 1,000 pods running on that node, you probably have a pretty beefy system. We've seen up to like 64 core systems. And Kubernetes makes it very easy for you to allocate a CPU core and memory to the NewVector enforcer if you need additional headroom. You have a high throughput transaction based environment that's running on that node, then you can simply allocate more resources to the NewVector enforcer.
Okay, and then we have a question from Walker. Is there a performance hit by inspecting the traffic on each node?
Yeah, I think we basically talked through that, a little more detail on that. And just to reiterate what Jorn said, in the monitor mode, we're like a tap or a mirror. So, you're not going to have any performance to the app connection. If we're in an inline blockable firewall mode, then of course we're going to have to hold that connection while we inspect it for attacks and make sure that it's not violating a whitelist rule. And so what we've seen is, single digit latency impact of that to the application, as well as I mentioned, you can increase the total throughput of the enforcer if you have, thousands of connections by allocating a CPU core to the NewVector pod.
Yeah, the reality is that the footprint is surprisingly low. We're not hairpinning things back to some sort of appliance. This isn't a WAF. NewVector, again, it's a very tiny footprint for the amount of power that you're getting.
Okay, and then it looks like Gobin has asked to, for more details and a private demo. I'm going to go ahead and send Glen's information and Jorn's information to Gobin.
Yes, please.
For additional demo, Gobin, you can definitely, I just went ahead and sent their information to you. Just reach out to them directly, and then we will also contact you back as well and respond to that. We are hitting the top of the hour. Jorn, Glen, if there's anything else you guys want to say, last remarks before we end the webinar, go ahead and feel free to do so right now.
No, I really want to thank everybody for being here. I know we went through a lot in a short amount of time. We can go deeper on a lot of these topics. And like Glen said, we have a few times we get some very informative webinars where we've gone really deep, and we're delighted to do one-on-ones with folks at any time.
Oh, don't forget to download the automation guide if you haven't done so. That's in the resources on the right of your interface. But yeah, this was fun. 4.0 just came out about a week ago, so it's really exciting, and we're happy to show you that and work with you on it.
All right, great. Thank you everyone for attending. Have a good rest of the week.
Thanks, everyone.
Cheers.